This video is part of the lecture for multivariable calculus, and I'm going to talk about graphs and contours of a function of two variables. So let me start. We're talking about graphs, and graphs help us to visualize a function. So we're going to see how to visualize a function of two variables. Two variables is very interesting, actually. So f of x and y, a graph of a function of x and y, is basically a surface in a space, and it's defined by z equals to f of x and y. And this surface is actually, as you see, we have two dependent variables, two actually independent variables, x and y, and so that's why we have 2 degrees of freedom, and z is a function of x and y. Z is usually the height of our function. And then for each x and y, we plot the point x, y, and z where z is equal to f of x and y. So I'm going to explain everything in examples. So example 1, I'm going to graph f of x and y equals to negative y. Well, I'm going to say that in this case, I have z equals to negative y. So I'm going to graph z is the third coordinate. So z is equal to negative y. And basically, I'm going to find all the points x, y, and z where z is equal to negative y. So I should say that when z is equal to negative y, x is free. If I plot z equals to negative y in yz plane, I just have a line. But now that I'm in R3, x is free now, so that's why I get a plane. It's a plane. So let's see how I graph it. I have x-axis, I have y-axis, and then I have z-axis. This is z-axis, and then z equals to negative y in yz plane would be this line in here. Let me graph the line like this. This is z equals to negative y, and now x is free and I'm in R3. That's why I get a plane, because it moves along the x axis. So I get a plane like this. Yeah, it's a plane. Okay, let me show it to you in here. You see, this is z equals to negative y, and this axis in here is x-axis, this is y-axis, and then this is z-axis, and this is z equals to negative y, as you see. Yeah, if we are in, you see, yz plane, it would be just the line, but now I have it like this. Okay, look at the second example. Example 2, I'm gonna graph f of x and y equals 1 minus x squared minus y squared. Okay, so we need to graph z equals 1 minus x squared minus y squared. But I have all 3 variables here, so it's a little hard to see. That's why I use this procedure to graph it. I'm gonna look at the trace of the graph in coordinate planes. Coordinate planes. Okay. For example, let me write it in here. In YZ plane, x is equal to 0, so I'm gonna plug in x equals to 0 here. I get z equals to 1 minus y squared. Now let me graph it in YZ plane. This is a parabola upside down, right? And when y is equal to 0, z equals to 1. So starting it here, I'm gonna have a paraboloid. When z equals to 0, y squared would be equal to 1. Y is plus minus 1. So I have a parabola like this in YZ plane. Now in XZ plane, y is equal to 0, so I'm gonna get like the same thing. I'm gonna plug in y equals to 0. I get 1 minus x squared, which is the same, but in XZ plane, right? It's upside down parabola. Now in YZ plane, not YZ plane, XY plane. In XY plane, z is equal to 0. So I get 0 equals to 1 minus x squared minus y squared. And so I get x squared plus y squared equals to 1. What is that? Let me bring up a little bit here. So as you see, this is a circle of radius 1, right? X, y, this is a circle of radius 1. Now just see, in YZ plane I have a parabola, in XZ plane I have a parabola, and underground I have a circle. I get this shape. X-axis, let me try to graph it. Y-axis, and then Z-axis. So I have something like this. I have a circle of radius 1 down here. Then I have a parabola like this. Now let me bring everything down. I have something like this. So it's called paraboloid. And the paraboloid is like spinning parabola, z equals to 1 minus x squared about the z-axis, right? So let me show it to you, the graph of that. That was the plane. This is the graph of the paraboloid z equals to 1 minus x squared minus y squared. You see, x-axis, y-axis, z-axis, and I have upside down parabola. Paraboloid actually. It looks like this. Okay, there is another way to graph some functions that are hard to visualize and hard to see the trace on coordinate planes, and we're going to use contours for them. So I'm going to talk about contours now. So have you ever seen the weather map? The weather map is something like this. For example, you have like a region, like a country, and then you have some curves or some lines that with some numbers on it, something like this. For example, they say that at this all the places that are at these lines, they have 50 degrees temperature or 40 degrees temperature for everything that lies in here. Or if you go hiking, you might see a contour map like this. For example, some lines at, for example, 1,000 feet at the level elevation of 1,000 feet, or like, I don't know, 2,000 feet, or maybe there's a mountain with some numbers on it, 5,000 feet elevation, and then I don't know, 8,000 feet elevation, something like that. So this is the weather map, and this one, it's called the contour map with the elevations. So the contours in graph, they have the same idea. The contours are gonna show, so contours show all the points on the graph where f of x and y is equal to a fixed number. And these fixed number, we usually choose them at a regular interval. And these contours, they also called level curves of the function f. They look like this. So x-axis, y-axis, and for example 1, 10, 15, they call the level curves of f. So in contours, we kind of slice the graph of f of x and y equals to z by horizontal planes z equals to c. Then we project all these slices into xy plane. Okay, so something like that. Just assume that we have the surface of a graph like this, and it's in, this is z-axis. Just assume this is z-axis, this is x-axis, and for example this is y-axis, and then we basically slice it with this plane, and this is the slice. We slice it with z equals to some other numbers like this, and then we get, for example, this shape. And then these level curves, I'm gonna basically project them down like this in xy plane with some numbers. For example, this is z equals to c1, this is z equals to c2, and I'm gonna write c1 and then c2 in here. Okay, let's look at one example and see how to find the level curves of that. As an example, the level curves of f of xy equals to negative y. We saw that z equals to negative y, it's a plane that runs through x-axis, and then I'm just gonna slice it with z equals to some numbers. And when I slice the plane, I just get, so assume that I have a plane like this, and if I slice this plane by z equals to something, I just get a line right? So I get different lines, and then I'm gonna project all these lines into x, y plane, and then for example I get the line like this. Let me make it a little bold. I get this for f equals to 0. I get this line in here. So for f equals to 1, so you see when f or z basically equals to 1, I get y equals to -1. So this is f equal to -1 would be like this. If equals to 1, I get the line y equals to -1. When f is equal to 0, I get y equals to 0. When f is equal to -1, I plug in -1, I get the line y equals to 1. If f is equal to, for example, 2, oh, actually, let me make it -2. I plug in -2 in here, z equals to -2, and then y is equal to 2. So these are all the level curves that I get, and then if the level curves align, I see that I get the plane. Let's look at one more example. And the example is to write the contours of f of x and y equals to 1 minus x squared minus y squared. So what are the contours? So the contours, or the level curves, I'm gonna say if I set f is equal to 0, I get 1 equals to x squared plus y squared. I get a circle of radius 1, like this. And I'm gonna put 0 in here just because this is the level curve f equals to 0. I get a circle of radius 1. I forgot to label my axis. And then if f is equal to 1, I get what? I get 1 equals to 1 minus x squared minus y squared. So x squared plus y squared would be equal to 0. And all the points with the coordinates that satisfies this would be just the origin, just 1 point. This is at level curve 1. And then when f is equal to, for example, 2, I plug in 2 in here. So 2 minus 1, which would be 1. So I get x squared plus y squared equals to -1. This doesn't have a solution. No solution. It's just because x squared and y squared, both of them are positive. And then f equals to -1. I plug in -1 in here, and then I bring 1 on the other side. So I get x squared plus y squared equals to 2. So it's a circle of radius square root of 2, something like this. Let me just move this one to the center, and this is the circle of radius 2 for the level curve -1. Okay, so as you see, for this paraboloid I get circles, and then just assume that you're given these circles, and then you just give them heights, and you get paraboloid. These are the contours for z equals 1 minus x squared minus y squared. These are all circles of different radius, and when I project them into xy plane, I get concentric circles.